So here's lesson 3.6 about polynomial and rational inequalities. Basically, we have four different nonlinear inequalities that we can look at. Less than, greater than, less than or equal to, or greater than or equal to. I'm basically going to break this down the way that I would treat it, and then hopefully it will make sense to you. So the first thing we want to do when you see a problem like this is relate it to 0. So let's distribute the x and subtract the 15 so it's related to 0. And then we want to see the factors. Now the reason we want to see the factors is if we see the factors, then we can look at where it is equal to 0 to help guide us, okay? So this function has a 0 at 5 and at -3. Now, what I'm going to make here to the side is called I call it a plus-minus chart. So we're going to make the number line, and we're going to put on the number line those zeros we just found, okay? Now, if, like in this case, we see an equal to bar right there, then we're going to put closed-in dots. If we didn't see an equal to bar, we would put open circles, okay? And then I'm going to make this into a chart. I need, because there are two factors, I need 2 rows. And to the side here, I'm going to write each factor individually. Okay? Now, I am going to think along the number line, and I'm going to pick a number to the left of -3. It can be any number to the left of -3. A number between -3 and 5, so I'll pick 0, and the number more than 5. Now, it can be any number within that region. I'm going to call that my test value to see what is happening. And so if we look, let's plug them into each of these and see what we get. And I only care about whether I'm getting a positive or a negative value. So here I'm going to get a negative, because -4 minus 5 is -9. And here I'm going to get a negative. Now, these two are touching. See right here, this is a multiplication. So a negative times a negative, because they're multiplied, will give me a positive. Now, my inequality was less than 0, which means negatives. So I don't want that region. If I wanted that region, I would color it in. Now let's plug in 0. I get a negative and a positive. If I multiply a negative and a positive, I get a negative. I want that region, so color it in. Now let's plug in 6. 6 minus 5 is a positive. 6 plus 3 is a positive. A positive times a positive is a positive. I don't want that, okay? Now, what is our answer? Well, our answer, I want you to put into interval notation. It's any value from -3 to 5, including those values in a bracket, okay? Now, how does this line up graphically? Well, if we were to graph into Desmos or otherwise, x squared minus 2x minus 15, this is what it looks like. And where is this graph under 0? Well, from -3 to 5, it is under 0. It is negative. So that is why this answer from here to here is our answer. So the graph sometimes can be very, very helpful to us, and we'll talk about that more as we go. Let's do another one. So make sure it's related to 0. It is. Make sure it's in factored form. It is. So now we really can just jump right in to starting our plus and minus chart. So you're going to take x minus 2, set it equal to 0, and solve. We're going to take x plus 3, set it equal to 0, and solve. Okay. We're going to put those values on a number line from least to greatest. We're going to turn this into a chart. We have 2 factors, but we want to actually account for the fact that we have a square on that x minus 2, and then we have an x plus 3. Now, let's pick our test values. Our test values are, well, I'm going to go -4, 0, and 3. We're going to put open circles here because of the fact this does not include the equal to bar, okay? So if we plug our -4 into this one, -4 minus 2 is going to be -6, but when we square it, it's going to be a positive. -2 plus 3 is 1, so that's a positive. Oh, I'm sorry, no it isn't. -4 plus 3 is -1, that's a negative. Sorry about that. And then a positive times a negative is a negative. We want this time greater than zeros, which means positives. So since that's a negative, we're going to ignore it. Let's do our next one. Let's plug in 0. 0 minus 2 is -2. Square that, get 4. That's a positive. 0 plus 3 is a positive. A positive times a positive is a positive. Color that in. And then let's plug in 3. 3 minus 2 is 1. 1 squared is 1. That's a positive. 3 plus 3 is 6. That's a positive. Color that in. Now let's think about what we know about the graphs of these. Remember what we learned about polynomials. This has a bounce at 2. This has a slice through at -3. Since it's a cube, going to be acting like a cubic, this side's going to go down, this side's going to go up. It's going to go up, bounce, and then keep going. Now, what are we looking for? Well, we're looking for the positive region. That's this piece. I'm sorry, we're looking for the positive regions, which is this piece and this piece, okay? And so we have to skip this piece at 2, and you can see the graph. Their graph's much prettier, but the graph matches up with what we want. Now let's put our answer in interval notation. Our answer is from -3 to -2. We use parentheses since those are open circles, and then we go from, and this is positive too, goodness. And then we keep going from 2 to infinity, okay? So that is our answer to that one. Let's take a look at this one. So we want to put it into factored form. I think this is a good example of slide and divide. Let's slide the 4 over. We're going to multiply it by the 25. We're going to pretend like this was our problem. And then we got to divide off the 4. That isn't divisible by 4. That's 5 over 2, and that's 5 over 2, so that's 2x minus 5. So put that in, and that's technically that value squared. Now we only have one 0. So our only 0 is 5 over 2, okay? Look at our inequality here. We have a less than or equal to, so we are looking at negatives, and the 0 will be closed in. And so let's make our plus minus chart. We only have 5 halves. The only thing in our chart is 2x minus 5 squared. Okay, so if we plug in something less than 5 halves or 2.5, let's go with, let's plug in test values. Let's plug in 2 and 3. If we plug in 2, that's 4 minus 5. When we square it, we get a positive. And if we plug in 3, we get 6 minus 5. When we square that, we get a positive. We only want negatives. So the only point we have is the point 5 halves. Nothing is positive. Or I'm sorry, nothing is negative like we wanted. Everything is positive. And so our answer is that x equals exactly the point 5/2, and nothing else is going to work. If we were to graph it, the only place where this is negative or 0 is the point right there, because everything else in the graph is positive, so we don't want that. So the graph should line up. Now, using this exact same plus-minus chart, we can answer the next question. Where is it less than 0? Well, if we look at the plus-minus chart, these were positives. This would be an open circle. We would not color anything else. That's a no solution. There's no place that it's less than 0. And then if we change the symbol one more time to greater than or equal to 0, well, at 5/2, we would have a colored in dot. And then these are positive and these are positive, so we would color it in to the left, we would color it in to the right. Our answer is everything from negative infinity to positive infinity. Because the question is where is this graph greater than or equal to 0? Well, everywhere. And so that's why we get that answer. So by changing that symbol, we can get very distinct answers. Now, let's take a look at how we deal with rational inequalities. Well, we want it in factored form. We want it related to 0. That doesn't change, except now we have a numerator that might need changing, and a denominator. So this is already factored. We're going to set each piece equal to 0. I would note, or make yourself some little note, that, hey, that one came from the bottom, and we'll discuss why that's important in a minute. So we've got 1, -3, and 4. So still, we're going to make our plus-minus chart. We're going to put those in least to greatest order. I am going to use the symbol here for anything on top. So this tells me that the zeros from the top are colored in, so they're a closed dot. Okay, so the zeros from the top are these two, so that's -3 and 1. The 0 from the bottom, because that would be undefined, it always gets an open circle. So when doing these, I immediately put the closed and open circles on the zeros depending on which ones come from the top, and that is completely related to the symbol, and which one comes on the bottom. The bottoms are always open. Now, I'm going to turn this into a chart. The rest acts just like a polynomial. I'm going to put my factors, x minus 1, x plus 3, x minus 4. So you'll notice this time I have 3 separate columns, or rows, I'm sorry. And then let's come up with some test values. So let's go -4, 0, 2, and 5. There's an infinite number. You pick what you want. So let's plug them in. If I plug -4 into each of these, I get a negative, and a negative. 3 negatives when multiplied is a negative. If I plug in 0, I get a negative, a positive, and a negative. 2 negatives make a positive. If I plug in 2, I get a positive, and a negative, which is a negative. If I plug in 5, I will get a positive, and a positive, which is a positive. Now remember what the symbol tells us. Less than 0 means I only care about negatives. And so now let's color in the negatives. And then let's write our answer. Our answer goes from -infinity to -3, and I can include that -3. And then there's another piece from 1 to 4. I can include the 1, so I put a bracket, but not the 4 because it came from the bottom, so I put a parenthesis. If you were to graph it, so here's -3, here's 1, and over here is 4. There's technically an asymptote here. So what does that mean? Well, that means we are looking for negatives. So the graph was negative here, was here, and was positive up there. So that's why we have those two sections. So the graph and your algebra should line up. Let's take a look at number 7. Now the problem with number 7 is the 3. The 3 needs moved. So subtract it. Now normally it wouldn't be necessarily super helpful to deal with the 3, but we have to deal with the 3. So we're going to put that 3 over 1, and we're going to get a common denominator of x minus 7 by multiplying top and bottom by x minus 7. Okay, and we get x minus 5. Now I'm going to distribute the negative and the 3 to each of those. And I get negative 3x plus 21. And then combine everything that you can, and we get negative 2x plus 16, and x minus 7 is less than 0. Okay? So what do we know? Well, the top is determined by that. It's a less than, so it's an open circle for the top values. The bottom is always an open circle. So let's set those equal to 0. Negative 2x plus 16 equals 0 at 8. X minus 7 equals 0 at 7. So let's put those on our plus minus chart in least to greatest order. We're going to take, now really we only care about this one, the one that's ready and is ready to go. Put our factors, negative 2x plus 16 and x minus 7. Since the top has no equal to sign from the 8, that's going to be an open circle, and then the bottom always gets an open circle. Now let's pick some test values. Let's plug in, let's go with 0, because 0 is nice to plug in. Let's do 7.5, and let's do 9. Okay. If I plug in 0 to the top, I get a plus. 0 in the bottom, I get a minus. A positive and a negative multiply or divide and give us a negative. Let's plug in 7.5. I get a positive here. I get a positive here. A positive times a positive is a positive. Let's plug in 9. I get a negative. I get a positive, so that is a negative. Now our symbol was less than, so that means we want negatives. And so color in the negatives. So our answer is from negative infinity to 7 in a parenthesis, and then from 8 to infinity in a parenthesis. So if you look at the graph, let me make sure that I did everything the way I needed to. Yeah, I think so. Yep. So this part of the graph is negative. This is the part I need to look at. So something's a little weird. Let me just, give me a second here. Oh, let's put it into Desmos here. I've got all these tabs open. Let me get that ready. Okay, so let's put it the first way. X minus 5. I must have made a weird mistake. I'm looking for it here. Give me a divided by x minus 7 minus 3. Oh, no, that's good, actually. Look, that is correct. This graph they have over there must not have been exactly the way I did it. So do you see how, here, let's scooch it over a little bit. From 8 over, it's under 0, negative, and then this whole section is under 0. So yeah, oh, it's okay. Okay. I didn't do anything funky. Well, you know. Now let's try number 8. So, again, we have to have it related to 0, or this isn't going to work. So let's subtract this piece from both sides. So we're going to go 1 over x plus 6 is greater than or equal, no, let's subtract. So minus 3 over x minus 2 is greater than or equal to 0. Now, we need to have this to be one individual fraction, or the things I showed you earlier are not going to work. So I'm going to multiply this one by x plus 6 on top and bottom. And I multiply this side by x minus 2 on top and bottom. So I'm just getting common denominators. So I get x minus 2. Now I'm going to take the negative 3 and distribute it. So that's negative 3x minus 18. And then leave the pieces on the bottom separated. So leave the x minus 2 and the x plus 6. Just leave them separated. Okay? Now let's combine all the junk we have on top. So we have negative 2x minus 20. Okay? Now it's ready to go. So now we're going to take each part and set it equal to 0. Now this one came from the top, so its 0 is going to be colored in. So remember that. It comes from this. These two zeros come from the bottom. They will not be colored in because zeros don't exist in our denominator. Remember, those were excluded values. So let's make our chart. Put them in least to greatest order. Okay, now let's fill in. Negative 10 came from the top, so it's an equal to, so it's closed in. But negative 6 and 2 came from the bottom, make them open. Okay, now let's make our chart. We have 3 pieces, so I'm going to need 3 rows. 1 for negative 2x minus 20. 1 for x minus 2, and 1 for x plus 6. Let's come up with some test values. Let's do a negative 11. Let's do negative 7. Let's do 0 and 3. Again, multiple, I'm just picking those numbers kind of at random as long as they're in that region. Okay, if we plug it into the top, we're going to get 22 minus 20, which is a positive. We're going to get negative 13, that's a negative, and negative 5, that's a negative, and then 2 negatives multiply and give us a positive. Now remember, we're looking for positives. So color that one in. Okay, let's plug in negative 7. We're going to get 14 minus 20, that's a negative. Negative 7 minus 2 is a negative. Negative 7 plus 6 is a negative. 3 negatives make a negative. We don't want that. Let's plug in 0. Negative, negative, positive. That's a positive. We want that. Color it in. Let's plug in 3. We get a negative. We get a positive. We get a positive. That's a negative. Don't want it. Our answer's right here. Our answer goes from negative infinity to negative 10 with a bracket. And then from negative 6, not in a bracket, but in a parenthesis, to 2, also in a parenthesis. So there is that. And if we looked at the graph of the stuff when it's related to 0, let me show you. So 1 divided by x plus 6. This is a way to kind of check that your algebra is right. Minus 3 over x minus 2. So I just took it from the first subtraction. What do we see here? Well, if we look at our graph, we have a section that is positive. It's kind of hard to see, but at -10, it is a 0, and then it goes over top of the x-axis. It becomes positive at 10, because down here, see, it's negatives, positives, negatives, positives, negatives, positives. And then when we get to -6, which is right here, see, -6, up here it becomes positive, and it stays positive until we hit 2. So I gotta scroll all the way over here till 2. Oop, I'm sorry. See here at 2, it stays positive, but look on the other side. These are all negatives. Okay, so it has these weird regions. So it has a piece over here and then a piece in the middle, and that's what we see. So we did it right, which is good. One last little question. It says, Fumia, sure, is constructing a circular koi pond in his backyard. What range of values may he have for the diameter of the pond if the area is to be no more than 78.5 square feet? So what we know is that the area has to be between 0 and 78.5, okay? And we know that area is pi r squared. And so first let's get a range for the radius. So we would have to divide by 3.14. And 78.5 divided by 3.14 is 25. And now since these are all positive values, we can square root it. So the radius has to be between 0 and 5. Now it asks for the diameter. So the diameter is 2 times the radius. So if we double everything, we get the ranges for our diameter. So that's that. And then one last one here. The cost to produce X items is given by this function. If the cost is to be kept below 20, how many items can be produced? So the cost has to be less than 20. So let's turn it into one of the problems we saw. Let's subtract 20 from both sides. I say it, but I didn't do it. Now let's get common denominators for everything, which would mean we would have to multiply here by x, because that's a 1 really, and then here by x. And we get, I'm so sorry, we get 0.5x squared plus, well, let's put it in descending order, minus 20x plus 150 over x has to be less than 0. Now, let's do a little bit of thinking here. Let's multiply top and bottom times 2, because it doesn't affect the inequality, it doesn't affect anything, but it will make our top one look a little nicer. So we're going to get x squared minus 40x plus 300 over 2x has to be less than 0. Okay. Now let's factor this top. 30 is 10 times, or 300 is 10 times 30. So that means that it factors like that. And we can do exactly what we did in the earlier problems. So we have zeros from the top of 30 and 10. They would be open circles. And then the bottom has a zero of 0, which is open circle anyway. Let's put them on our chart in least to greatest order. Let's write our factors along the side. Let's put open circles. Let's choose test values. -1, 5, 20, 40. Let's plug them in. So we want negatives. So if I plug in -1, I get a negative, and a negative, and a negative. 3 negatives make a negative. Now, yes, you can color that in, but can we produce a negative number of products? In the real world, this case is not really going to work. Let's plug in 5. We get a negative, and a negative, and a positive, which is a positive. Don't want that. Let's plug in 20. We get a negative, positive, positive. So we want that. That's a negative. Let's plug in 40. We get a positive, and a positive, and a positive. We don't want that. So we want to produce the number of items we want to produce has to be between 10 and 30. Now we don't include 10 or 30 because it says we want to be below 20. They didn't say or equal to 20. They said below 20. So it has to be that the number items produced should be somewhere between 10 and 30 would get us what we want. Okay? So thanks so much for watching. I hope this helped you understand rational inequalities. So you have a wonderful day, and take care. Bye.